Let's look at some important ideas from 2.3. Can you get there from here? So, first we learned in this lesson that congruent figures are the same shape and size. Okay, so congruent means exactly the same in shape and size. When we're talking about polygons, this means we have congruent angles and congruent sides. So everything about the polygons are congruent. All right, so if we want to prove that two figures are congruent, well, to do that, I need to show some rigid transformations. Remember, rigid transformations are like rotations, reflections, and translations. So we need to show rigid transformations to move one figure onto the other. So we know that rigid transformations, rotations, reflections, and translations don't change their shape. And so we want to move one object onto so that it lands right on the other one. And if we can do that, then we can say they're congruent. Now, a good strategy that we came up with for doing this is kind of a three-step part. All right, so here's the idea. If we have a triangle here and we make a copy of it, and so we got maybe A, B, C, and we've got D, E, F, something like that. So if we want to map or move this one to there, we came up with a general strategy to first transform, or translate, we should say, translate the image, the pre-image, till 2 points coincide. Okay, 2.2 corresponding. And we got a new word here, coincide, all right? What does coincide mean? It means they are on top of each other. They land on each other. So if we move this shape here, maybe we move this until A kind of goes over to D there, because they're the same. They look like they're the same point. They're corresponding. So we move that over, and then step 2 is to rotate till two sides line up. Okay, now we've got to rotate around a point, so but we want two sides to line up or to coincide. Okay, two congruent sides, so we can make this AC line up with this DF there. All right, and then step 3, if needed, we can reflect across that common side. All right. Okay, so that we found was pretty useful. We'll practice that in a second. Okay, once we've showed that two figures are congruent, we know that the corresponding segments and angles in the figures are incongruent because we know that corresponding parts, corresponding means parts in the same spot, corresponding parts of congruent figures are congruent. Okay? In other words, let's write this down, are congruent. Okay, so in other words, if you have two congruent shapes like these triangles, all the corresponding angles are congruent and all the corresponding sides are congruent. Okay? So we got this word corresponding. Corresponding angles are angles that are in the same relative position. We can also have corresponding sides, and it just means they're in the same relative position. Okay? So different parts can be corresponding. Sides to sides, angles to angles. Okay? So let's practice that. Let's practice those 3 steps we just wrote down there. So we have this triangle here, ABC, and we want to move that over to RST, and we want to describe some steps. So one good way to do that is to trace the triangle. If you have tracing paper or patty paper, you can take that triangle and trace it. And then let's try some steps here. Let's try our 3 little steps that we wrote above. Let's start with translating. Let's take this shape here and let's translate it until A coincides with R. So let's take that A down to that R. So that's our first step. So we're going to translate that triangle ABC until A coincides with R. Coincides, again, just means lines up. All right. So now let's take that, and we can kind of rotate it. Like you can see this little dotted line giving us a hint there. So what if we rotate it until it lines up there? All right. So if we take this here, now let's imagine I can't do it on the iPad here so well, but we're rotating it. We should lock it onto R when we really rotate it. Okay. And we can land it there. So if we rotate it about R, so R would be our center. Okay. And then it'll land. We can say, well, how far do we rotate? Well, we're going to rotate it until B corresponds with S, or specifically AB corresponds with RS. So let's rotate ABC till, and let's say till side AB coincides with RS. Okay? So there you have it. AB corresponds to RS. Now what do we need to do? Well, the only thing we need to do now is we need to reflect. Remember, when we do a reflection, we need to reflect across the line. Well, what line do we want to reflect across? We want to reflect across RS. And when we reflect across RS, this is going to land right over there. Okay? So our last step will be to reflect ABC across RS. So reflect triangle ABC across line RS. All right? So there's 3 quick steps, and we can see that will line up right there. And I think we can all agree on that. So since they line up, that means they are congruent. So that's the big ideas from this section there. All right. We're going to look at a couple other examples here, some retrieval stuff here. But that's the steps that we can do to show that 2 things are congruent if we can show using rigid transformations, rotations, translations, and reflections, that they're the same. There's a couple other things we're going to practice here in this lesson in the retrieval problems. So I'll go over those real quickly, and you'll have that so you can do your assignment. All right, so we have, first, let's review going back to last unit, how we reflect this triangle HMS across the line y equals x. Now, this is the line y equals x here. Y equals x is a slope of 1. And if you want, it has a y-intercept of 0. It's in slope-intercept form, slope of 1, y equals 0. Or you can think of the points where y equals x, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. This is the line y equals x. The slope, rise over 1, is 1 over 1. Now, a little reminder here, when we reflect, if I have a point here, like point A, would I reflect it over to here? Is that A prime? No, that's not A prime. That's not A prime because we didn't reflect perpendicular. So when we do a reflection, we've got to go perpendicular. So if I have a point A here, I need to travel perpendicular. Well, what's the perpendicular slope? Well, if the slope is 1 over 1, to find a perpendicular line, our slope is a negative reciprocal. So if we flip these around, 1 over 1, flip it around, we get 1 over 1. But we're going to change the sign. It's going to be a negative reciprocal or an opposite reciprocal, and we get negative 1 over 1. So we're going to take this point, and we're going to travel along a line of negative 1 over 1. So this little dotted red line, that has a slope of negative 1 over 1. And you see how that's perpendicular to this? So when we have these lines that have a slope of 1, it's really easy to go perpendicular to them. Okay, so a little reminder there. So we can find, if I had this point A down there, then this would be A prime. and we go the same distance across, all right? So we're going to count in kind of these diagonal distances. So let's find the new S. So S, we're going to travel along a line of -1, a slope of -1. So from corner to corner. So there's one, let's call that one diagonal space. And so I'm going to go one diagonal space to the other side. And there's S prime. H, well, to get to the line, I do a half a diagonal space. Another half a diagonal space is H prime. Okay? M, all right, now careful here. We're going to travel from diagonal to from corner to corner. There's one diagonal, trying to get to the line. There's two diagonals, and there's three diagonals. So I traveled three diagonals to get from M to the line. So you see that? 1, 2, 3 diagonal spaces. Now I need to go continue across. 1, 2, 3. There's the new M. Okay? So now I can draw my lines in here. And there's my new triangle. Okay? That's the idea. Okay, so that's how we travel perpendicular to the line of reflection. We go the same distance across. All right? So a little review on graphing here. So another thing we're going to practice in this assignment. So for our graphing, first thing we need to do is draw an X and Y axis. Now it's not drawn in because that's something that we want you to practice. Okay, where should you draw it? Well, these lines here look like they're pretty close to the origin. Okay, if they weren't, then we might want to draw these lines at different spots. So we have our X and Y axis there. You don't need to fill all the numbers in, but a good practice to get used to is to write at least one number on the axes. So you could put a 1 or maybe go on over to 5 and write 5. Okay, you don't need to label every single mark, but you need something that tells the scale. Okay, so let's remember how you do this, all right? So we got this in slope-intercept form. So we have y equals mx plus b. So what number is in the b spot, the y-intercept? That's -2. So we're going to have a y-intercept of -2 for this line. What's the slope? Well, the slope is 3/2. So we want a slope of 3 over 2. That's the number in front of the x. So that means a rise of 3 and a run of 2. So we're going to go up 3 and right 2. Up 3, right 2. Okay, and we'll get a few in there. Use a ruler, use a straight edge to draw a nice, neat line here. Okay. Put some arrows on the end of it because these go on forever. Lines go on forever. All right. And then we've got this other line, y equals -3x. So -3/2 x, that is. So here's our m. Our slope is -3/2. And the b is 2. So the y-intercept is 2. And the slope is -3/2. So that means we're going down to the right. Down 3, right 2. So from here, down 1, 2, 3, right 2. And we've got a point right there. Then we're going down 3, right 2. We've got a point right there. Again, using a ruler, get a nice straight line. Whoops, that's not a very straight line. Let's try that again. Use my little magic tool here. Okay. Put some arrows on the end of it there. Goes on forever. All right, there you have it. Slope of 3/2 and -3/2. Are they perpendicular? Let's think about that real quickly. They're not, are they? This is not 90 degrees right here. They look like they should be, but what would you have to change with their slopes to be perpendicular? Right now they're not perpendicular. Can you tell what you'd have to do? Well, they'd have to be reciprocals. So if this was the reciprocal, if this was 2/3 and this was -3/2, then they would be perpendicular. Or if this was -2/3. One of them needs to be reciprocal to be perpendicular, but these are not. All right, Well, we'll leave it at that. So now we got some reminders of how to do that stuff. So you should be able to do your assignment, and hopefully you're all caught up. All right, keep working hard. Thanks a lot.